Hello, everybody, and welcome to Chapter 4, Lesson 6, Complex Numbers. Our essential question is, what are the subsets of a set of complex numbers? What I will learn, or what you will learn, is how to define and use the imaginary unit I, how to add and subtract complex numbers, and how to multiply complex numbers. So the imaginary unit I. So as we know, not all quadratic equations have real number solutions. In the previous sections, we've been solving equations, and if we have something that has no solution, we write no real solutions. So, for example, if we had an equation like x to the power of 2 is equal to -3, this will have no real solutions. Because if I try to solve this by taking the square root to both sides of the equation, I would get x is equal to the square root of -3. And as far as we know, there is no such thing as the square root of a negative number. So we can't do that. So to overcome this problem, what mathematicians did is they created a new number system that included an imaginary unit I. And what we did is that we defined I as the square root of -1. So this I simply means the same thing as -1. Okay, so if we do I to the power of 2, that's equal to -1. Okay, so that's the rule for imaginary numbers. So what I'm going to start off here is I'm going to use that idea to solve these square roots. So I have the square root of -25. So obviously I can't do that, right? We can't take the square root of a negative number, but with what we just learned with the imaginary unit I, I'm going to break this square root up into the product of two square roots. I'm going to say 25 times the square root of -1, right? Because 25 times -1 is -25. So I'm just breaking this up so that I have these separate, because I know that the square root of 25 is equal to 5. And if I take the square root of -1, well, we know now that the square root of -1 is the same thing as I. So the square root of -25 is equal to 5I. And that's what we write as our simplification of that square root. All right, let's try another one. So here I have the square root of -72. So again, I'm going to break this square root up into something that I know how to find the square root of. So what I'm going to do here is I'm going to take the square root of -72 and I'm going to break it up into a product of various square roots. And what I want to do is I want to break this up so that the 72 gets broken up into some number like 25, because I know what the square root of 25 is. And 72 is not a perfect square, so we can't take the square root of that. We are looking for numbers like 4, because that's 2 times 2. We're looking for numbers like 9, that's 3 times 3. 16, that's 4 times 4. 25, that's 5 times 5. 36, that's 6 times 6. 49, and 5, that's 7. That 8 is 64. 9 is 81. But as you can see, none of these are 72. So, but I can see that 36, if I multiply 36 times 2, that's 72. So what I'm going to do is I'm going to use the 36 to break up this square root. So I'm going to say 36 times square root of 2, right? Because that gives me 72. And then I'm going to multiply that as well times our square root of -1. Okay, so then I'm going to start solving this. Square root of 36, I know that's a perfect square root, so that's going to give me 6. The square root of 2, I don't know, so I'm just going to go ahead and bring that down right here to be the square root of 2. And then last but not least, I know that the square root of -1, now we write as just I. So the simplified version of the square root of -72 is 6 square root of 2 times I. All right, and last but not least, we have negative 5 times the square root of negative 9. Okay, so then this one, what we're going to do is I'm still going to do, so the negative 5, because it's on the outside of the square root, we don't have to worry about it. Let's just leave it outside, leave it to the end. And then my square root of negative 9, I'm going to write as the square root of 9. I'm going to leave it as a 9 because 9 is one of our perfect roots. So that's going to give us a 3, and then I'm going to multiply that times a negative 1 because that we have this negative 9 here. Okay, let's bring down our negative 5, right, that we're not touching. Square root of 9 is 3, and then the square root of negative 1 is I. So this square root of negative 1, that's I. So then all I have to do is multiply my two numbers here, negative 5 times 3, which gives me a negative 15, and I bring down my I. So the negative 5 times the square root of negative 9 is equal to negative 15I. All right, so complex numbers. So a complex number is written in standard form is a number a plus bi, where a and b are both real numbers, and I, of course, is our imaginary. The number a, so if I have a plus bi, this part right here, this is the real part of our complex number. So a complex number is a mixture of real numbers and imaginary numbers. A is the real part, bi is the imaginary part. So how do we tell the difference? This is the components of complex numbers. So if b is 0, so for example right here, if b is 0, if there's no b, okay, then that means there's no imaginary part. So that means that if b is not equal to 0, so b, that means that this is a real number. So that means if b is not equal to 0, like if b is something else, then that means that we do have a, and then we have an imaginary part. We have a real part and an imaginary part. So then that would be an imaginary number because it's a combination of a real number and an imaginary part. So if a is 0, so if there's no a, like this, where there's no a, all we have is the imaginary part. We call this a pure imaginary number. It doesn't have a real part to it. All right, so what we're going to do is we're going to solve an equality of two complex numbers. So we have, so here let's go ahead and focus and see this. This is 2x minus 7i is equal to 10 plus yi. Okay, so this is an equation. We're going to find the values of x and y. So to solve an equality of two complex numbers, what we do is we set up an equation based on the real parts and the imaginary parts. Okay, so what I'm going to do here, I'm going to draw a line down the middle. On the left, I'm going to solve an equation using the real parts. Okay, so I think it's going to be easier if we do the imaginary part first. So I'm going to circle the imaginary part. So that one's easier to find because it's the one that has the I. Okay, so I'm going to set up an equation using those two. So I'm going to say negative 7i is equal to yi. Okay, so because the 7i is on the left side of the equation, I put it on the left side of the equation. The yi is on the right side, I put it on the right side. So I'm going to do the same thing with our real parts, 2x and 10. So I'm going to set that up over here. 2x is equal to 10. So we want to keep everything on its same side. So because there's an equal sign, I'm going to keep it all the left side on the left side of the two equations that I make. So 7 and 2x stay on the left. Okay, and now all I have to do is I have to solve for each of our variables. So if I start with my real part, so 2x is equal to 10. To solve for x, I need to remove the 2, which I have to divide. So then I would get x is equal to 5. And then on this side, to leave the y by itself, I would divide both sides by the letter or the number I, because I is an imaginary number. So divide by I, that cancels, that cancels. So then I'm going to get y is equal to -7. So my two answers here are x equals +5 and x equals -7. To add and subtract complex numbers, it's kind of like the same idea. So here, let's go and write my expression. I have 8 minus I plus 5 plus 4I. So with that being said, we can only combine the real parts with real parts, imaginary parts with imaginary parts. So I'm going to start by identifying my real parts. So I have a +8 and a +5. So because I am adding, I'm going to add 8 plus 5. So that's going to be 13. Center that a little bit, 13. And then my my imaginary parts are -I and 4I. So I would add those two together. -I, 4I gives me +3I. So the sum of those two complex numbers is 13 plus 3I. And let's make sure that we remember that this is standard form. The real part goes written first, and then the imaginary. So real, then imaginary. All right, our next one is a difference, is a subtraction. So 7 minus 6I minus 3 minus 6I. Okay, so with subtraction, okay, we got to pay attention to what we're doing. Okay, so what I like to do is I like to take this negative, this subtraction, and I like to make it a plus, but in order to do that, I have to change the signs of everything inside. So I'm going to change that to a negative and this to a positive. Okay, so I like to do that first. That way I don't forget that I am subtracting, not adding. But now that I've changed the signs, I can now add the numbers. So let's go with real parts. I have a +7 and a -3. That gives me a 4. And then if I do my imaginary parts, I have -6I, +6I, -6I, +6I. That gives me 0, 0I. So I don't need to write that. So the difference of those two complex numbers is just 4. All right, last example we have is multiplying complex numbers. And we're going to do this the same way kind of that we did with our polynomials. We're multiplying binomials. 9 minus 2I times -4 plus 7I. So what I'm going to do is I'm going to take my first complex number, 9 minus 2I, and I'm going to do distributive property. So I'm going to do 9 times -4 plus 7I, and then I'm going to get my -2I and also multiply it times my -4 plus 7I. So then I'm going to get 9 times -4, that's -36. 9 times 7I is, just multiply the numbers, keep the I, so that's 63. I, then negative 2I times negative 4. Negative times a negative is a positive 8I. So kind of treat I as a variable, except for this next part, we're going to do negative 2I times 7I. So here I'm going to multiply the 2 times 7, which is a negative 14. And then the I times the I is the same as if you were being multiplying a variable. You're going to add the exponent, so I to the power of 2. So here we're going to need two things that we're going to have to do. I have like terms, 63I and 8I, sorry. So that's going to be 71I. I have my negative 36 I'm going to bring down, plus. And then I have something else that I have to simplify. I have basically this right here, I to the power of 2. So remember back in the rules for I to the power of 2 is equal to negative 1. So I'm going to replace this I to the power of 2 with a negative 1. So I'm going to bring down my 14, minus 14. And then instead of the I, I'm going to write I squared. I'm going to put negative 1. So I to the power of 2 is the same thing as negative 1. I have to simplify this multiplication here. Negative times a negative. That's positive 14. Bring down the 71. I bring down my negative 36. And then here I have one last step. I can't have all three of these terms. They're still like terms. I have negative 36, positive 14. I combine those two together to give me negative 22. Bring down my 71I. Remember that the real part goes first, and then the imaginary. So that's going to be my complex number solution here. So I have negative 22 plus 71I as my answer. All right, that's the end of the lesson. You should have learned how to find the square root of a negative number. You should have learned what complex numbers are, how to add and subtract complex numbers, and how to multiply complex numbers. If you have any questions, comments, or concerns, please feel free to drop them in the comment section down below. Thank you for watching, and I'll see you next time.